everyone, I'm Nupur K and I love math. So this week's math video is going to be about the concept of stones and bones. Now suppose you and your friend are having a donut party. You bring half a dozen donuts and of course you're planning to split them with your friend. Now you're trying to think, well, how many ways can I split the donut with my friend? I can have 0, 1, 2, 3, 4, 5, or 6 donuts. And because my friend doesn't believe in food waste, she'll have the rest. Your friend and you are not exactly sure how you plan to split the donuts. How many ways you can split the donuts, I meant. So you decide to line up the donuts in a neat row and put a divider somewhere in that row so that any donuts on the left would be yours, but any donuts on the right would be your friend's. For example, if you put the divider over here, then 3 donuts would be yours and 3 donuts would be your friend. However, suppose you manage to convince your friend to let you have all the donuts, you would put the divider over here. Your friend gets nothing and you get all 6. So how many ways are there to put this divider? Well, you have to choose one of 7 places to put the divider. 1, 2, 3, 4, 5, 6, and 7. Seeing as there's 7 possible spots and you have to choose one, the number of ways to do this is 7 choose 1, which is just 7. Well, you're probably thinking, I could have tried out all the possibilities and found that myself. That's true, which is why we'll now go to a more complicated problem. Now this time, you've been put in charge of 3 8-year-olds. Being 8-year-olds, they're currently in their slime phase, so you decide to stock up on 20 containers of slime to split between the 3 of them. Now there's a catch here. Each 8-year-old demands at least 1 slime container. None of them will settle for leaving without slime. So how many ways are there to divide them this time? Well, now, suppose you just decide to give 1 to each. So this way, you've taken care of the
I don't want to leave without slime.
So now you have 17 containers of slime left. You decide to figure out how many ways to divide them. So of course you repeat the same procedure, laying out all 17 slime containers in a line and trying to divide them. This time, seeing as you have 3 8-year-olds, you need 2 divisors so you can partition the slime containers into 3 parts. The one on the left, the one in the middle, and the one in the right. So this time you notice that there are actually 18 ways to place these divisors. You can place 16 between 2 containers, and of course there are 2 more spots in the beginning and the end. And there are 2 divisors to place. So the amount of ways you can divide between these 8-year-olds would be 18 choose 2. 18 choose 2 is equal to 153. So this time there are 153 ways to split it. Now let's try another problem. So in all of these previous examples, we had to divide an exact number of items, exactly 6 donuts, exactly 20 containers of slime. But here we're introducing a twist. Suppose you're distributing candy between 4 of your friends, but this time, in total, they may take up to 30 candy. All of them can refuse candy, then you'd still have 30 candy left. Or all of them could use up all the candy, and then you'd have an empty bag. So now what do? You might think that there are 31 cases. 0 candies taken, 1 candy taken, 2, 3, 4, 5, 6, 7, 8. All up to 30. But then we're ignoring the fact that we're dividing them between 4 people, not just 1. This brings in so much more complications. What do? We can't count all of those cases. It's just too much work. Then you remember, well, you do have a greedy pet mouse who's willing to take whatever candy is left. So if all of your friends take 28 candy, then the mouse would be left with 2. But if they only take 3 candy, your mouse will have a very good day eating 27 candy. This hugely simplifies the problem. Instead of trying to divide up to 30 candy with 4 people, you're dividing exactly 30 candy with 4 people and a mouse. I am not going to draw 30 pieces of candy and 4 dividers to make 5 parts. So you're just going to have to imagine it in your mind. If there's a row of 30 candy, there'd be 29 spaces between the candies, 1 on the start and 1 on the end. So that would make 31 spaces to place 4 dividers. So of course the answer would then become 31 choose 4, which is equal to 31,465. We sure were right when we said there were going to be a lot of possibilities to divide this candy. Well, in these 3 problems, we talked about the fundamentals of the counting technique known as stones and bones. I hope everyone understood and that this video helped you, more importantly. I'm glad to be talking about this with you. So I'd like to say thank you for listening and bye!